All right, we're going to start with section 1.1, which is all about graphing skills. First, we're going to talk about our Cartesian coordinate system. Another name for a Cartesian coordinate system is rectangular. So rectangular coordinates are all based upon your typical XY axis. Make sure in this class you are always labeling your axes. First quadrant, using Roman numerals, second quadrant, third quadrant, and fourth quadrant respectively. So thinking about what quadrants are the x values always positive, clearly that would be the right half of the coordinate plane, which would be quadrant 1 and quadrant 4. And in what quadrants is the product of the x and y coordinates positive? We know a positive times a positive is a positive. That would be quadrant 1 where both x and y are positive. And if both the x coordinate and the y coordinate are negative, a negative times a negative happens to be a positive. And we know that in quadrant 3, both the x and y coordinates are negative, so we're also going to include quadrant 3 here. All right, let's take a look at the next problem. So a little bit of review, we're going to talk about the distance formula and midpoint formula. So we're given 2 points. Point A is negative 4, 5. Let's go ahead and plot that. 1, 2, 3, 4. And we're going to label that in point A. And point B is the point 2, negative 3. That's point B down there. And we're trying to find the midpoint of segment AB. All right. So let's label that on the graph and we'll find these values without using the formulas. So first let's use the formulas. We're going to say the distance formula, the difference between the two x coordinates. If we take a look at 2 minus negative 4, so I'm going to say 2 minus negative 4, really 2 plus 4 quantity squared. And the difference of the two y coordinates, I'm going to say negative 3 minus 5 quantity squared. This becomes 6 squared plus 8 squared, or the square root of 36 plus 64. Square root of 100 we know is 10. So the length of that segment, AB, is 10 units. And the midpoint is going to be halfway between the two. So we're going to be able to calculate that value using the average of the two x coordinates and the average of the two y coordinates. You'll see this on the test. Make sure you show this calculation. The average of the two x coordinates, that's going to give you the x coordinate of that midpoint, and then the average of the two y coordinates. Add them up, divide by 2. That's your average. Let's simplify this. We wind up getting negative 2 over 2 and 2 over 2 respectively, or the coordinate of negative 1, 1. Let's plot that and just check to make sure it looks good. There it is, right there. We're going to call that midpoint M. And if we calculate kind of the slope here, just visually, it looks like we went down 4 over 3. And if we repeat that again, we go down 4 over 3. That shows you that same slope is indicative that that is in fact the midpoint. So that's the other way you can do it without using the respective formulas, but make sure you can do both methods. All right, let's look at the two formulas in this box down here. First one is the distance formula given 2 points. First point is x sub 1, y sub 1, and the second point is x sub 2, y sub 2. We know in general the distance between those 2 points is the square root of the difference in the x coordinates squared, and we're going to add to that the difference in the two y coordinates and square it. Make sure your square root goes all the way over, and that's the distance formula. For sure need to know that on this test. Midpoint is simply the average of the two x and y values, or in this case, add up the x values and divide by 2. add up the two y values, and divide by 2. All right, the last one on this page is a little bit more complicated. We're going to plot each of these points, point A, B, and C, to form a triangle. Let's go ahead and do that. A is -6, 3. B is 3, -5. And point C is -1, 5. And so we've got a triangle there. And we'll connect these real quick. So it looks like angle C is the angle in question. We're trying to figure out if this one is in fact a right angle. So we're trying to figure out if this is a right triangle or not. I'm going to show you two different ways to prove this. The second one is going to use the converse of the Pythagorean theorem. First way is a little bit easier. We're going to figure out the two slopes here. So the one for the slope of line AC or segment AC, and one of segment BC. So the slope of segment AC, just a quick slope calculation between those 2 points. Difference in your y coordinates looks like 5 minus 3 all over -1 plus 6, or 2/5. The slope of segment BC, difference in your y coordinates, 5 minus -5 or 5 plus 5. Difference in your x coordinates, -1 minus 3. So we get 10 over -4 or -5/2. Looking at these two slopes right here, because they are opposite reciprocals, therefore we can say that segment AC is perpendicular to segment BC, and knowing that we have one right angle, creates a right triangle. So that's the first way. The second way is a little bit more complicated. It uses the converse of the Pythagorean theorem. All right, looking at this triangle, it looks like segment AB is the hypotenuse. So I'm going to say the Pythagorean theorem would state, if this is a right triangle, segment AC, or the length of AC squared plus the length of BC squared, should equal the hypotenuse squared. So if that's true, it must be a right triangle. Let's see if that in fact is true. Go ahead and calculate the lengths of all 3 of those segments. All right, this is what it should look like when you're done. Segment AC, the length of segment AC is √29. The length of segment BC is 2√29. And the length of segment AB is the square root of 5 times 29, or the square root of 145. Now we're going to go plug everything into this formula to see if in fact they are right triangles. So we'll say √29 quantity squared, 2√29 quantity squared, and that should be equal to the square root of 5 times 29 quantity squared. So it looks like we get 29, and square the 2, square the √29, so we wind up getting 4 times 29. And on the right side we get 5 times 29. So both sides, in fact, wind up being 5 times 29, or 145. So in fact, they do check. This is a right triangle because it satisfies the converse of the Pythagorean theorem. All right, this next section talks about first whether we can recognize if an ordered pair satisfies an equation. We have 3 points to figure out if each one is on the curve. And again, remember, only the points on this graph are going to satisfy the equation, giving us a true statement when we plug them in. So show what you're doing. We're to first plug in 0, 0 here. Please make sure you show that we are plugging in 0, 0. And when we plug that in, we wind up getting 0, 0 cubed is 0, 2 root 0 is 0. So we wind up getting 0 equals 0. This happens to be a true statement. And again, what that means is if we graph this equation, the point 0, 0 is on its curve. Second point. Again, show what we're plugging in. We evaluate it for y, and then 1 cubed minus 2 root 1. This is 1 minus 2. Or 1 is equal to negative 1. That is not true. So this one over here is not on the curve. Definitely not, does not satisfy this equation. Last one. If you plug this one in, we get negative 1 for y. 1 cubed minus 2 times 1. We get negative 1 is equal to negative 1, which is a true statement. So these two are definitely on the curve, and they satisfy this equation. All right, this next question, whenever you're in doubt, you can't figure out how to graph something, you can always resort to a T-chart and plot the points by hand just by simply plugging in numbers. Go ahead and do that right now. I'll go ahead and fill this out and go ahead and do that quickly on yours. Fill out this T-chart. All right, when you're done, it should look something like this, a little bit of mental math, just plugging these values in. And let's talk a little bit about graphing in this class. Again, we're gonna label our axes. In this case, this is y and x. Notice it's not f of x as this was labeled y equals on this side. And let's see if we can label a scale real quick. So we've got some points there. 1, 2, 3, 4, 5, 6, 7, 8. I'll go by twos. And let's see if we can plot this. So we'll plot some points. And I'm going to label all of my intercepts. This is the point 0, 1. Down here is 1, 0, and negative 1, 0. And let's plot a few more points, negative 2, negative 3, 2, 3, and then 3, negative 8. So this is a parabola that opens down. Let's see if we can graph this. Hopefully yours is a little more rounded than mine up there at the top. And whenever you're graphing this, make sure we label our intercepts. And this curve is the curve negative x squared plus 1. Please make sure you label your curve. If it's f of x, label it f of x. If it's g of x, make it g of x. In this case, it's negative x squared plus 1. All right, this next one is graphing an equation with your TI graphing calculator. First thing you want to do is put it in a form that your graphing calculator can use. We always solve for y, so in this case, we're going to rewrite this and say y1 in our calculator is going to be negative 3x squared plus 18. You need to show this. Make sure you are always showing, if you're plugging in your calculator, always show that step. So a little bit about this graph. We know that this is a parabola. It is x squared. And we know it opens down because the coefficient of the x squared term is negative. So I'm going to say it opens down. And we should be able to find our two intercepts. Our y-intercept, occurs when x is equal to 0. So if we plugged in 0 for x, we wind up getting 18. You can also look at that from the perspective of this has been shifted 18 units up from a transformation perspective. Likewise, we're going to find our x-intercept. We're going to let y equal 0. If we let y equal 0, we wind up getting 0 equals 3x or negative 3x squared plus 18, or 3x squared is equal to 18. Divided by 3, we get x squared equals 6, and square root in both sides. Make sure you have a plus or minus in there. This is an exact value. Notice it says list the intercepts as exact values, and you can use your TI to find approximate values. Make sure you know the difference between these two. Plus or minus the square root of 6 is an exact value. And if you enter that in your calculator, and you should have a pretty good guess of where it is between. If we think about that square root of 4 is less than the square root of 6, which is less than the square root of 9. I know it's somewhere between 2 and 3. So if you type this into a calculator and get something like 18, you know you did something wrong. But square root of 6, that is about 2.449. This is an approximation. And just like calculus next year, everything we do in this class will be to 3 decimal places. And we rounded that off in our calculator to the nearest thousandth, but that is what makes it an approximation. All right, let's sketch this graph. So we're going to show this intercept up here at 18. We'll label this y and x respectively. And 1, 2, 3, 4. 1, 2, 3, 4. And we're just going to sketch this parabola that opens down. We know it passes through right here. And again, about 2.4 on both sides, somewhere around there. Somewhere around there. This is a parabola that opens down. Looks something like that, and we called it y1. I'm going to label it y1 on my graph as well. And let's label these points here. This is our y-intercept of 0, 18, and this an exact value is root 6, 0, and negative root 6, 0 respectively. Make sure we are labeling those intercepts. An appropriate window, if this is done on your graphing calculator, it looks like we went from negative 3 to 3 on the x. And again, I'm just looking kind of if I was going to cut it off, I'd cut off about there and about there. So negative 3 to 3, and then maybe from negative 5 to 20 would be an inclusive window so we could see that entire graph. All right, let's take a look at this last one down here. This is a common test question for this first chapter. All right, we're given 2 points. We're given point A, which I've shown over here on the bottom left. And it looks like we're also given the midpoint in the middle, and we're trying to find the coordinate of the other point in this segment. So if this is the midpoint, somewhere over here is going to be point B. So the midpoint is going to be halfway between A and B. We're going to show you 2 approaches to this. The first one is a graphical approach, and the second one is going to use the midpoint formula. So you want to have that algebraic approach as well as that graphical approach, 2 approaches. First one, we're going to look at kind of the slope between these 2 points, between point A and the midpoint point M. It looks like from negative 2 to 5, we went up 7 units. And again, that's just the difference of the y coordinates there. And from negative 3 to 1, it looks like we went over 4 units. If we repeat that, meaning we go up 7 and over 4, we should be able to find the coordinates of point B. So we look at the y coordinate, we're just going to say 5 plus 7 is going to be 12. So we know the y coordinate is 12, x coordinate 1 plus 4 is 5. 5, 12 should be the coordinate of point B. Let's take a look at the algebraic approach, and obviously we should get the same answer there. but you definitely need to be able to show this. We know that if we take a midpoint, okay, we take a midpoint, want to find just the x-coordinate. We take the average of the two x-coordinates. That should be the x-coordinate of the midpoint. And same thing for the y-coordinates. If we take the average of the two y-coordinates, that should give you the y-coordinate of the midpoint. So let's see what we know. We definitely do not know this second value right here. So we don't know our second coordinate. So let's plug in what we do know. We know the first x-coordinate is -3. And we'll leave this as just an x. And we know the x-coordinate of the midpoint was 1. And for the y-coordinates as well, we get -2 plus the y-coordinate of point B. And that should equal our y-coordinate of our midpoint, which is 5. Now, we've got two simultaneous equations. We can solve them independently. Let's see if we can do that. Multiply both sides by 2 and add 3. And multiply both sides by 2 and add 2. Our midpoint winds up being 512, which confirms what we got over there.